Let's start with a reality every maintenance and reliability professional already knows. We have more data today than at any point in industrial history. And yet we often don't know what to do with it. Every single day, the plant generates vibration trends, running currents, SCADA temperature and pressure traces, oil analysis reports, alignment and precision maintenance data, SAP work orders, OEM telematics, operator shift logs, and thousands of alarms and events. But here's the real problem. All of this data is siloed, disconnected, fragmented, and we get more of it every single day. We're drowning in information while starving for insight. Across industries, the pattern is the same. Work orders are completed, PMs are done, oil samples are analyzed, vibration routes are logged, SCADA records every second. Operators notice minor anomalies. Nothing is missing, except the connection between the signals. A high-load conveyor gearbox failed unexpectedly. Failure number 1. The data was there, but not together. When the first failure happened, the site already had correct failure mode in SAP, proper corrective action recorded, PMs done on time, vibration data stored, SCADA temperature trends archived, oil analysis results, operator shift notes. Every dataset existed, but each one lived in its own system. Individually, nothing looked alarming. Together, these signals formed a clear deterioration pattern, but no one saw the full picture. Result: $180,000 in downtime and lost production. Failure number 2, predictable, but still not predicted. 8 months later, the same gearbox failed again. This time, all the warning signs were there, but each was viewed in isolation, compared only to its own threshold. SCADA temperatures were rising, but still below the alarm limit. Vibration harmonics were increasing, but under the vibration alert threshold. Oil samples showed where metals trending upward, but not high enough for a lab red flag. Operators reported a slight smell, but nothing serious enough to escalate. SAP showed tighter PM cycles, but without understanding why. And here's the crucial point. We check individual values, but we rarely check whether they are trending up or trending down. A reading that is within limits today can still be moving steadily in the wrong direction, but no single system sees the combined trend. SCADA doesn't know vibration is rising. Vibration systems don't see oil where metal's increasing. Oil labs don't see temperature drift. SAP doesn't see operator concerns. Operators don't see load-driven stress patterns. Each system sees one pixel. None sees the picture. This isn't incompetence. It's the limit of isolated systems, each living in its own world. And it's exactly why the gearbox failed again. So what is plant data? ISO 14224. To understand the solution, we need to understand what data really is. ISO 14224, the global standard, defines 3 core categories. A. Equipment data, what the asset is, hierarchy, manufacturer, design attributes, environment, duty cycle. B. Failure data, how it fails, failure mode, cause, mechanism, detection method, impact. This becomes the reliability language. C. Maintenance data, how we restore or prevent failure, corrective maintenance, preventive maintenance, PM findings, components replaced, man hours, downtime. Together, these form the digital life story of every asset. Why structured data matters. Structured data reveals patterns, feeds predictive models, enables accurate RCAs, supports FMEAs, enhances comparison across assets. Unstructured data hides risks, breaks trend visibility, confuses models. The goal isn't more data. It's connected, structured, meaningful data. Priority of data for AI-enabled reliability. Not all data matters equally. Here's what matters most. Priority 1. Condition monitoring data. Failure modes and causes. Operating context and load. PM quality data. Anomaly and early warning signals. Priority 2. Useful for optimization. Repair history. Environment. Spare parts quality. Priority 3. Supporting only. Cost data. Man-hours. High-level KPIs. AI prediction stands on priority 1 data. Here's how modern reliability turns raw data into strategy. 1. Data integration. SAP, SCADA, CM, oil labs, telematics, unified. 2. Pattern detection. AI identifies wear-out curves, trending deviations, anomalies, PF intervals. 3. Strategy generation. AI proposes CBM, hybrid strategies, interval optimization. 4. Cost risk simulation, downtime cost, spares, labor, risk. 5. Engineering control, review, refine, approve. 6. Automatic CMMS updates, SEP/Maximo updated with audit trail. 7. Continuous learning, new data improve prediction. AI doesn't replace engineers, it equips them. Modern plants don't suffer from a lack of data. They suffer from too much data spread across too many systems, viewed through isolated thresholds, without a unified view of trending behavior, and no intelligence layer connecting it all. AI-enabled reliability closes that gap. Data unified, patterns revealed, strategies generated, failures prevented, engineers empowered. That's the future we're creating with Next-Gen Mate. Join us as we turn this vision into practice and make AI-enabled reliability as indispensable as SCADA is today.